about binomial expansion. Hence, obtain the expansion of f of x in descending powers of x up to x cubed. So from the previous part, we have this from the partial fractions decomposition, and from the MF19 we have the binomial series formula. So for the first term, this is the one in blue. So we have minus 2x plus 3 all over 2 plus 3x squared. So we move this using negative power upwards. So we have 2 plus 3x squared all to the power of minus 1. And now we cannot use this formula, of course, because n is positive, this is negative, so we cannot use this formula. And we cannot directly use this formula for now because this is 1 plus x to the power of n. So this is 1. This is not 1. We cannot use the formula right now. So we have to make it 1 plus something. So we have to factor out the 2. So we still have 1 plus 3x squared, because if we multiply we get 2, if we multiply we get 3x squared. So next step, remember this 2 is also to the power of minus 1. So the 2 is also to the power of minus 1. And to the power of minus 1 is 1/2. 1/2 times everything here we have minus x 3/2. So now we can use the binomial expansion formula, this formula. So identify the n is minus 1, and the x. In the formula we have x squared and so on, but in the question this is 3x squared. So we have to use this 3 over 2x squared for the x in the formula. So this is 1 plus n times x. In case you are wondering why don't we continue with the next term, well, because it says the expansion is up to and including x cubed. So x cubed means if we continue here, we're gonna get something with x to the 4th power, and that is wasting time because we don't need that. So we stop right here and simplify. This is minus 3/2 x squared. Now we multiply. Minus x times 1, we get minus x. Minus x times minus 3/2 x squared, we get plus 3/2 x squared. And I mean x cubed. 3/2 times 1, 3/2. 3/2 times minus 3/2, we have minus 9/4 x squared. So if we arrange in ascending powers of x, we have the constant and minus x and the square and the one with x cubed. Okay, now we do the next term, which is the 5 over 2 minus x. So 5 over 2 minus x, we use negative power. Again, we cannot use the formula because this is 2. We have to factor out the 2. If we multiply, we get the original. So 2 is also to the power of minus 1. 2 to the power of minus 1 is 1/2. So here we have 5 over 2. Now we use the binomial expansion MF19 formula. The n is minus 1, the x is minus 1/2 x. The minus is included. So this is n, this is the x, this is n minus 1, this is x squared, n minus 1, n minus 2, x cubed. Okay, now we simplify. Plus 1/2 x, and all cancel out, plus 1/4 x squared, all cancel out with the negative, but the negative cancel out with this negative later, so it's positive, and we have 1/8 x cubed. So we multiply everything by 5/2. 5/2 times 1, 5/2 times 1/2 x, 5/4 x. 5/2 times 1/4 x squared, 5/8 x squared, 5 halves times 1/8 x cubed, 5/16 x cubed, and now we have to add everything. For the constant, 3 halves plus 5 halves, that's 8 halves, which is 4, and minus x plus 1/4, minus x plus 5/4 x, so that's plus 1/4, minus 9/4 plus 5/8, so that's minus 18/8, plus 5/8 minus 13/8, 3/2 plus 5/16, so 24/16 plus 5/16, 29/16. Okay, we're done with the expansion until x cubed. Next part, state the set of values of x for which the expansion is valid in exact form. So if you look at the MF19 formula, we have this rule here. The absolute value of x should be smaller than 1, and the x is the x in this expansion. So for the first expansion, the x is not 3x squared. The x is, well, when we use the binomial expansion formula, the x is 3/2x squared. So we have to use 3/2x squared. Modulus of 3/2x squared is less than 1. So here we have modulus of 3/2x squared less than 1. We can divide both sides by the modulus of 3 halves, so we get x squared is smaller than 2/3, and then we take the square root both sides. We have x is smaller than square root 2/3, and we do the same thing with the green expansion. Remember again, the x is not this minus x, but it's minus 1/2 x, because that's when we start using the formula. So minus 1/2 x smaller than 1 modulus, so modulus of 1/2 x, you wanna cancel out, you gotta divide both sides by the modulus of, don't forget the modulus here, we cancel out, so you have 2. Okay, so if you don't use modulus and you get minus 2, you flip the sign, it's gonna be wrong. Okay, so we divide by the modulus of 1/2. So now we have two inequalities. X is smaller than 2 and at the same time smaller than the square root of 2/3, so of course the intersection is just this guy here. This is already the final answer. Or if you rationalize the denominator, we can use this form, but they are the same exactly, actually. Right? See you again.